Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and today we have a rare Clover solving a bill puzzle situation. Don't tell Philip I'm doing this as just a nice little surprise for him because I had some extra time this morning. So we're going to be solving Bill's puzzle today. We're a little out of rotations, but it's always kind of a rare treat when I get to do a bill puzzle, so let's check it out. So we have normal Sudoku rules. So we're placing the digits 1 through 9, once each in each row, each column, and each 3x3 region. And also, in classic Bill fashion, this is a beautiful negative constraint puzzle. So what does that mean here? This is an XV Sudoku. So we are normally going to see X's and V's marked in the grid, and those will tell us that adjacent digits surrounding those X's or V's have to sum to 10 or 5 respectively, as in like the Roman numerals X and V meaning 10 and 5. However, this is a negative constraint puzzle and it has no clues marked in it, which just means that none of the adjacent pairs of digits can ever sum to 5 or 10. Now Bill has done a very cute trick here. We have a 1 in the middle of this region. None of the adjacent digits with 1 can sum to 5 when you add them to 1, or 10 when you add them to 1. So 4 and 9, which sum to 5 and 10 respectively, may not be adjacent to the 1. There are only 2 remaining cells where we could put the 4 and 9, therefore, here and here, and one of them sees a 9 already, so that is a 4 and that is a 9. Over here, 2 can't be next to 3 or 8 because those would sum to 5 or 10. 3 can't be there, so it must be there, and 8 must be there. 4 can't be with 1 or 6. This cell sees a 6, so that's my 1, that's my 6. 3 can't be with 2 or 7. This cell sees a 7, so that is a 2, and that is a 7. Let's see if we can finish off the rest of these corner regions before we have to kind of move inwards in this puzzle. So in this region, we still need what? We still need 2, 5, 6, and 8. 2 can't be in these cells because of the 2 there. 2 also can't be next to 3, so it goes there. So now we need 5, 6, and 8. There are 8s looking at these 2 cells, so there's going to be my 8. And I need a 5 and a 6. There's a 5 looking at this cell, so 5 right there, 6 right there. Hey, we finished that region. Let's see if we can do this one. So we still need here 1, 4, 6, and 7. 4 can't go in those cells, so it's got to go in one of those. 1's got to go in one of those. And where are we going to put 6 and 7? 7 can't go in those cells because they'd be adjacent to the 3, so 7's going to go in one of those. And 6 can't go here or here, so 6 has to go in one of those. And I believe that means we're just going to have to, unless I've missed something, hang on to that for now and move on to the next region. Here we still need 2, 5, 7, and 8. Can't put a 2 or a 7 adjacent to the 3. So I need to put my 2 and my 7 here. This cell already sees a 2, so that's going to be a 2, that's going to be a 7. Yeah, and that'll take care of this top right region. That's now 1, 6, 4, and 7. That all resolves. That kind of waterfalls out from placing the 7 in column 8. Here I need 5 and 8, and there's an 8 in column 9 already. So there's my 5, there's my 8. In this region, I need 1, 4, 5, and 9. These are going to be a 4, 5 pair because I see that. The 4 can't touch the 6, so that's a 5, that's a 4. And I need a 1 and a 9, and because there's a 9 in this top corner, I'll get a 1 here and a 9 here. Now, the next most fruitful place to look, I think, is going to be these rows and columns, because they are adjacent to the largest number of additional clues, and they only have 3 remaining cells to fill in each. So this has to contain a 1, a 5, and an 8. This can't be my 1, because 1 can't be next to 4. That would sum to 5. This has to be 6, 7, and 8. This can't be a 7 for a couple reasons. It's next to a 3, also it sees a 7. This can't be a 6 because it's next to a 4. Here I'm going to need 2, 4, and 9. This can't be a 4 or a 9. It can't be a 9 because 9 can't go next to 1. That would have a bad sum. And here I need 1, 2, and 6. This cell can't be 1 or 6 because 1 plus 4 is 5 and 4 plus 6 is 10. So that's a 2. And that leaves me with a 1, 6 pair. Does that give me anything as I move outwards into these outer rings? These are going to be 7, 8, and 9. This cell sees a 7, and also it touches these 2 2s, and 2 plus 8 is 10, so it can't be 8 either. That's a 9. And right here, I have 6, 7, and 8. This guy sees a 7. This guy touches 2 2s, so that is not an 8, because 2 plus 8 is 10. And these are going to be 1, 3, and 5. This can't be a 1 because it touches a 9. Over here I have 3, 5, and 9. This can't be a 9 because it sees a 9. And here I have 1, 2, and 4. This guy touches a 9, so it can't be 1 because 1 plus 9 is 10, and it also sees a 2 in its row, so it is a 4. 3 and 2 can't touch because those sum to 5, so that's my 1 and that is my 2. 1 and 9 can't touch, that places 9 in only this position right here. How about right here? I need 3, 6, and 9. Can't place a 6 here because 4 plus 6 is 10. Right here, I need 2, 4, and 7. This cell sees both a 2 and 4, so this is a 7. 2 can't touch 3 because 2 plus 3 is 5, so that's a 4 with a 2 next to it, and the 4 resolves the 4-9 pair and places a 6 there, resolving the 6, 7, 8. 7, of course, can't touch 3. This 5, 8 here, this isn't 1 because it touches the 4. We worked out that earlier, and now that we have an 8 in the column below it, it's not an 8 either. So we can eliminate 5s from those positions. This is now not a 5. We have a 1 in row 6 now, so that's going to be a 6 and a 1. And these digits are going to contain 3, 4, and 5. That's not a 4 because it sees that 4 there. And it touches a 7, so it's not a 3 because 7 plus 3 is 10, so that's a 5. That makes this a 3 since it now sees a 4 and a 5. And it makes that a 4. And the 3 and 5 resolve this 3 and 5. In this row, we still need a 1, a 6, and an 8. This guy sees a 6, so it's not a 6. And now if we look vertically, we have a 1, 8 pair, and we also have 2, 4, 6, and 7. So we only need 3, 5, and 9 in these cells. This one can't be a 9, that can't be a 9, so that's my 9. And this is either a 3 or 5. That's not 9. 9 can't touch 1 since that would sum to 10, so this is a 9 with an 8 right below it, and that's now a 1. Now in this column, we still need 1, 2, 3, actually this resolved because we just placed a 1. Thank you, pencil mark checkers. That's a 5, 3, and 1. That is a 5. These are 2, 3, and 6 to finish the column. I have a 2 right there. So that's now a 2. 2 can't touch 3, so that must be a 6. So that's not a 6, that's a 6, that's an 8, that's a 3 and a 6. My last 2 cells to pencil mark here are going to be a 3 and a 9, which resolve right away. And finally, there should be something that resolves these. I see this 3 here. It can't touch the 7 since 3 plus 7 equals 10. So that is an 8, 7, 8, and 7. And that is how you solve Bill Murphy's lovely XV Sudoku, Chum. Hope you enjoyed that. Hope you enjoyed a little Clover interlude where normally you'd be getting a Phillips solve. And I will see you again in a couple days. Check out this puzzle. It's in the description below this video. See you later.